Let's move on to another circuit. In this circuit, we have three light bulbs connected in the way that you can see there. And I have some switches there that I can open or close. Let's think about first, why do those light bulbs have different brightness? They're supposed to be identical. They're supposed to have the same resistance. But you can see that if you believe the animation colors, you can see that one is brighter than the other one. Is that correct? I don't know if you can see that from back there. You can see that this one is brighter than this one and that one. These two look the same brightness, but this one looks clearly brighter. How do we explain that? Because it has more current flowing through it, right? The brightness is related to the power dissipated by that resistor, by that light bulb, which is a resistor. The power, since they all have the same resistance, you can think of the equation I squared times R and compare that equation, the amount of power, for all of these resistors. So that equation tells you that the light bulb with the biggest current is going to be brighter if all the resistances are equal, right? So the one with the biggest current, of course, is this one, because the current coming out of the battery, let's say that that flow is the electron, so the current is coming out of the battery like this. That's a whole current I, and then that current splits in two. Half of it goes this way, and half of it goes the other way. So this one gets twice as much current as this one or that one. And the brightness of this and that should be the same, because they have the same resistance, they're connected between the same difference in potential. So that's what that's why those brightnesses look like that. Now let's open one of those switches. Let's open S1, which is the first one. That's not it. What do you think is going to happen when I open the switch, that switch? What's going to happen to the brightness of the light bulbs? He's saying all of the light bulbs should go out. They should go off. Mm-hmm. How do we know that? Right, so you now have a gap. If you open that switch over there, there is a gap now. And the current flowing out of the battery is going to encounter that gap. It's not going to be able to jump across the gap, so it has to stop. Right? So let's open that. If I can. I better do it here. Oh, there. So if you open it, doesn't look very open, but I opened it. Then the current is going to stop. All right. So that's what happens when you open that switch. If I close it, then the current can resume flowing. What happens to the brightness of the light bulbs if I now open switch number 2, which is the one over here? This one. What would happen if I open that one? What would happen to the brightness of all of the light bulbs here? Think about what would happen to this light bulb, and think about what would happen to this light bulb. So if you open that switch, then the first light bulb, this one, and this one will be in series, right? If you open this switch, then the current will have to go through this one, and then it will have to go through that one, right? So they will be in series. So you would expect that the brightness of this and that would become the same, right? Important question is, would this one be less bright or more bright when I do that? And would this one be more or less bright? Say that again? They don't. If you open them, they have infinite resistance, of course. And if they're closed, they have 0. The second light bulb to be slightly less bright than it is right now? All right. And the first one, the first light bulb, what's going to happen to that one? Well, let's see. I think we're going to have to write some equations to see what happens. Let's open it, first of all, and then do some equations to see why that is. So let's look at it. So we're wondering in the brightness of the light bulbs how they change it. So keep an eye on them. So the middle light bulb, of course, goes off. There's no current flowing through it. But look what happened to the brightness of the brightest one. It went down. And the brightness of the number 3 one, it went up. Right? Okay, so how do we understand that? How do we explain that? So when the switch is closed, this is what the circuit looks like. Battery, light bulb, switch closed. That's the circuit when the switch is closed, right? This is switch S2. Okay, so what is the current flowing through? We said that the light bulb 1 is going to be the brightest because it has all the current flowing through it. So the current of light bulb 1 is the total I. The current flowing through light bulb 2 is I divided by 2. And the current flowing through light bulb 3 is I divided by 2 also. Let me call this one light bulb 1, light bulb 2, light bulb 3. Okay, so that's when the switch S2 is closed. Now what's going to be the current when I open it? So when I open it, it's like I have a gap here. So the current is no longer able to go through that branch. So the current now has to flow in the circuit this way, that way, then it goes through this one, and it comes back to the battery this way. So now 1 and 3 have the same current. What is the value of that current? So this is all closed. Now the calculation when it's open. Now the total resistance of the circuit is equal to what? R plus R, 2R. Right? So you had before, you had a current that it was equal to the equivalent resistance when the switch was closed was 1 and 1 is 0.5. 1 in parallel with 1 is 0.5 plus 1, that was 1.5. Right? So the current when the switches were all closed was equal to the EMF divided by 1.5. Okay, let's keep that as a reference. When I open S2, now the resistance of the circuit goes to what value? 2R. It was 1.5 before, now it's 2R. Right? So that means that the current in the circuit now, the net current is going to be the EMF divided by 2 instead of divided by 1.5. So that current, what happened to that current? It went down. Right? So that is the current that was flowing through the light bulb number 1. So light bulb number 1 is going to feel that decrease in current and get dimmer. Right? Because the current for that light bulb is going from epsilon divided by 1.5 to epsilon divided by 2. So the current went down. Okay? So the light bulb, the current going through light bulb 1 before was epsilon divided by 1.5. After I open, it's going to be equal to epsilon divided by 2. Right? So it went down. So the brightness of light bulb 1 went down. So now that we understand now. Okay? But what happens to the brightness of light bulb number 2? What was the current flowing through that light bulb before I opened the switch? If the total current was epsilon divided by 1.5, then the current flowing when I had S2 closed, then the current flowing through the light bulb number 3 was epsilon divided by 3. Right? The current in light bulb 3 before was equal to epsilon divided by 3 because it's 1/2 of epsilon divided by 1.5. Yes? Epsilon divided by 1.5 was the net current flowing in that situation. What is the current flowing through that light bulb, number 3, after you open the switch? So now it's epsilon divided by the net resistance of the circuit. When S2 is open, the circuit is series 1 and 3. The net resistance is 2R. So what happened to the current flowing through the third light bulb? Did it go up or did it go down? It went from epsilon divided by 3 to epsilon divided by 2. Is that going up or down? That's going up, right? So the current in light bulb number 3 goes up. And the current in light bulb 1 went down. Yeah. How do I get epsilon divided by 3? So that was 1/2 of the current flowing through. Remember that the circuit is closed here, right? So it's 1/2 of the current flowing of the net current is what flows through 3. The net current is I is epsilon divided by 1.5, because this one and that one do 1.5 of resistance plus 1.5. So 1/2 of epsilon over 1.5. Okay? Okay, so that explains what happened to those light bulbs when I opened the switch number 2. You should be able to answer these questions about circuits, what happens when you open switch, close switch, and so on. You should be able to do that, right? That's one of the main skills that you need to have for this chapter. To analyze the circuit and know what happens to all the currents, all the voltages when you change this, when you change that. Okay, so I think that's good for that circuit. Let's try another one.